Okay. Sir, shall we start, sir?
Okay. Yeah, we can start.
Yeah, Vishwa?
So, good evening to one and all present here for the webinar. Today's title is based on the quantum plus AI fusion under an use case on generative music. I invite HR Mohan, Chair Events IEEE CS Madras to deliver the welcome address and resource person introduction.
Greetings and good evening to one and all. On behalf of the organizing units IEEE Computer Society of India, and ACM, I have great pleasure in extending a warm welcome to our today's speaker, Mr. Lakshminarasimhan Santhanam, members and my colleagues from the organizing units, and the participants joined the webinar through the Google Meet meeting platform, and those watching the YouTube streaming of this webinar. In the ever-evolving landscape of technology, a new frontier is emerging that promises to reshape our world in ways we can scarcely imagine. The frontier is quantum AI, the powerful fusion of quantum computing and artificial intelligence. It is a field that is generating immense excitement and speculation across industries from finance to healthcare, and it's not hard to see why. Quantum AI has the potential to solve complex problems at speeds that would make even our most advanced classical computers look like abacuses in comparison. At its core, quantum AI leverages the principle of quantum mechanics to process information in ways that classical computers simply cannot. While traditional computers use bits that can be either 0 or 1, quantum computers use quantum bits or qubits, which can exist in multiple states simultaneously thanks to the phenomenon called superposition. This allows quantum computers to perform certain calculations exponentially faster than classical computers. Now imagine combining this mind-boggling computational power of the pattern recognition and learning capabilities of artificial intelligence. That is quantum AI in a nutshell. It is like giving genius a superpower. The ability to analyze vast amounts of data, recognize complex patterns, and make predictions with a level of accuracy and speed that was previously thought of impossible. Today's presentation is about quantum AI fusion with an use case on generative music. The topic is chosen by the speaker, as most of us are currently familiar with generative AI. Now, let me formally introduce the speaker, a finance person by qualification, but become a technical person through the nature of work. Mr. Lakshminarasimhan is a visionary leader at the intersection of AI, finance, and enterprise transformation, driving innovation, strategic execution, and knowledge dissemination. As the founder of QAF Lab, a non-profit organization, Lakshminarasimhan is committed to shaping the future of enterprise strategy and agentic AI, LLMs, and RAG-driven transformation frameworks. A fintech solution provider and thought leader, Mr. Lakshminarasimhan specializes in complex topics like automation of consolidation of group financial statements and the integration of AI into financial decision making. LAX, this is how popularly Mr. Lakshminarasimhan is called. He is passionate about data-driven excellence. Currently, LAX is spearheading multiple pioneering initiatives, including Certified Enterprise Transformation Analyst Program, bringing strategy with execution using AI, Certified Algorithmic Bias Auditor Program, training professionals in bias detection, assessment, and mitigation through deep technical expertise, 1% club, and elite fostering conversation on what 99% cannot see, and master LLM. A big book of large language model, a comprehensive guide on the evolution mechanics and the applications of LLM. Lax is a sought-after speaker, has addressed top-tier industry forums, the unsung heroes of enterprise transformation in various stages. He is eloquent in topics like AI-powered enterprise transformation insights, quantum machine learning, deep finance expertise, and thought-provoking discussions on the future of work and innovation. With this introduction to the subject and the speaker, let me welcome Mr. Lakshminarasimhan to enlighten our participants on quantum AI fusion with the use case in generative music. Over to Mr. Lakshminarasimhan.
I think I was really excited to this session where I could spend some time sharing my expertise. I started my career as a chartered accountant, and I evolved myself as a finance technology techno-functional expertise in implementing ERPs and MI systems, management information systems. And in 2009, I did my Six Sigma Master Black Belt, where I inclined towards, more towards this data-driven, decision making and the process excellence and stuff like that. I think you should not mistake me that I'm just a finance guy, because I traveled towards finance and system. I did 3 masters, like Master of Software Engineering and System Design, Master of Commerce, and CA. And also I did Certified Information System Auditors. These are all my credits in the initial days. In the recent past, in 2017, I was part of the pioneer batch with the Great Lakes, PG in artificial intelligence and machine learning, and where the almost last 8 to 9 years I have been into the latest technologies. And recently in 2022, I did a certificate of excellence in quantum computing. That's out of my interest actually, because that's the future. See, the one most thing that we need to understand, if we picked up an IT role, every 6 months once, you have to keep learning something new. That is what, that maybe you can see me as a, living example of learning a lot many things. I used to keep setting goals, because learning makes people, younger. That's one of the things that I used to say. And, the most beautiful thing is we are in AI era, generative AI, and, the quantum is the next thing, next big thing. I think, at this point of time, that it is really an appreciable effort in CSI, that they are picking up the right right forum maybe to learn something that is going to change the way that how the industry works. Today, I don't want to bore you, running through a lot of, slides and stuff like that. That's not the way that I normally deliver certain, sessions, actually. I just want to show you, by the end of this session, you would be really overwhelmed, how we can use generative AI and quantum machine learning in enhancing the the human intelligence. That's what I used to say. So before we begin, let us touch base with our Indian the Bharat heritage, right? I used to touch certain certain reflection of our history, because I believe one thing very strong: we are not the people from the past. Indians, basically the people from the future. You should know why. Let me give you some interesting understanding for you guys. Maybe you can I think it should be more kind of a dialogue. It should not be monologue. You can ask questions, and you may intervene. Don't hesitate to ask questions. That's the most important thing that we need to learn in the AI era. Let me if we know that in Mahabharata there are two people who are delivering Bhagavad Gita, and the two people who are learning Bhagavad Gita. This is most important example to begin with. What we need to understand, where the AI is basically placed in our history. Krishna is delivering the Bhagavad Gita to Arjuna, that has been on the real time streamed by Sanjaya, who is delivering that to a blind guy, Dhritarashtra. You just need to take the understanding of this. This is very much important for us to understand what is generative AI. The power of generative AI is similar to Sanjaya. The two people who are discussing, it's a discourse, basically 700 lines of, oration, the verses of oration, I could say. Normally it will take 3.5 hours in a war zone. Somebody is talking lengthy, normally in our corporate world, most of the time that we listen, that if somebody who is talking more, we will brand them in such a way based on the Western definition, is less intelligent, talk less, more intelligent. Like that we will tell, I will ask the people, is Krishna intelligent or not, like that? Because between a war, 3.5 hours of delivery of 700 verses of Gita he is delivering, that has been streamed real time by Sanjaya with his power to a blind guy. What the blind guy knows, he knows nothing. He is just able to ask right question. He is asking right questions, like as a layman. He does not know anything, he's a blind guy. Just imagine. Now, let us come to our technology. Chat GPT or generative AI, whatever the name that you call, DeepSeek or, DeepSeek or this Gemini 2.5. All these things are like Sanjaya. I'm going to show you something, that would be very much interesting for you guys. How you can make use the potential of generative AI. When it comes to something, as a layman, I'm not aware of anything about the subject. I'm a blind guy. I'm just, I'm going to be a Dhritarashtra for some time, and I'm going to, inherit this Chat GPT has Sanjaya to help me to learn something that I am not aware of. I have never seen in my past. Actually, that's a interesting stuff that you will learn now. Okay, I will be giving 2 demos on generative AI, and I will give one presentation on the quantum, plus AI fusion, how it works basically. Why this is the pace of, I have adopted certain flow because it is easy for you to make out, what I am trying to tell in a progressive way. If you have any such kind of questions, and also I see that the audience might be having a mixed crowd, with always I used to have, if we approach, it should be easy to consume, and as well as progressively I will put certain complex things in this space. I have been coming with the background of psychopedagogy, that is something, classroom psychology. This is my today's progress, how I'm going to deliver this entire content in another 1 hour. And you are allowed to ask questions, and you can ask questions in such a way that, you don't need to hesitate for the end of the session. But ask questions in the chat. I would be able to collect those questions, and I think, the team will help me to, put across the right flow, and I will give you most of your doubts will be clarified in this session. Within this quantum and AI, how we fuse these two things, for betterment of humanity or human intelligence. The most important thing, that the first thing that I am going to, I am going to excite you in such a way that, how this Sanjay, how I will assign an AI as a Sanjay, and how I learn as a, as a Dhritarashtra. Let us, I'm going to present my screen. Let me know once you have seen my screen. Are you able to see some of the information? I think it's a Google
Yes, sir.
web page.
We are able to see the Google screen, sir.
Yeah, fantastic. Let me search for a prompt. Don't worry about these prompts. Basically, I will share these prompts to you guys, whoever is attending the session. I think once the session is over, I'm just using a prompt, and I am telling ChatGPT to be a Sanjay. You just see what it does. It says, wonderful. I am honored to serve as your master level guide. Let's begin with step one, initiating the journey. To design a truly recursive and mastery-based learning journey tailored to your pace and curiosity, I need you to specify the subject that you would like to deeply master. You may choose any domain. It may be any topic. Let me maybe, I think, ask you guys to suggest me any topic of your interest. I think it's easy for us, to use some linear algebra. When I type the topic, you can see what it does. First thing is, it is getting a kind of an organized layers. It will create a layer of what and all the sub topics within this particular given subject, and it is creating a kind of a modules. Let me come back to this. Let me take you through this prompt. What this prompt is exactly doing. I am telling that fascinate as a passionate master level tutor, guiding me, a layman, through any subject, using a recursive interview style pedagogy tailored to my pace and understanding. Your goal is to help me attain deep transferable mastery through dialogic learning, practical applications, and continual reflection. And it is in a question and answer mode, like a dialogic mode. Yeah, how Arjuna and Krishna has been, doing the discourse of Bhagavad Gita. Similarly, how the Sanjaya and Dhritarashtra is, in a dialogic mode. The same dialogic mode it is creating, and you can see that it is, throwing certain kind of a idea how to proceed as given subject. It says that you can use any of these topic. Maybe I would prefer in such a way some basic things that everybody will will be able to understand. And we will start with some foundation on vectors. What is linear algebra, geometry meets algebra, like that you can ask some questions. And I don't have any such kind of an idea of what actually linear algebra as a layman, and it is providing these many topics, and it is designing a courseware for me, and it is telling certain kind of uh, you know uh, idea to begin with. Let me say next. I don't say anything. I just want to progress on its own. As a Sanjaya, I will say next. This is the only keyword that I need to use mostly. It is starting from the lesson 1, where it is what is linear algebra, and it tells the vector, linear combinations, transformations, and system of equations and stuff like that. And what is the interesting part in it, if you are seeing the analogy, it is providing certain kind of an analogy. That analogy is very much a layman understandable language, and it is also give you certain questions like a Socratic probe. Let's challenge the intuition. If you add two arrows pointing in the same direction, what does the result look like? I think it's in the scale, right? And do you see what it happens here? It is in a dialogic mode. You can switch any questions and you can say next. If you say next, it will move to the next topic. If you started asking questions, it will answer the questions whatever that you don't have answer. Let me ask, can you reach all directions in a plane? And copy this and just put it here. This is actually very wonderful, tool that we have on our hand, that in our Indian education system, most of the time, we have been, as per my analysis, there are 2.1 billion way that every child that is born in India is being discriminated. We are not producing polymath in last 75 years post, independence. Forget about the British era. Our education system is continuing the same way how the British has provided to us. So we are schooling in such a way that for the jobs, we are not creating polymaths. Actually, in India, we used to have, everybody used to have at least more than more than 8 up to 64 skills. Our ancestors before the era of invasion. So AI will make us in such a way that learn many things. How we plan this way of learning things, that's most important thing. I used to say that the knowledge management is 4 different phases: awareness, mastery, maestro, and practitioner. Now what we have seen here is awareness is the most important thing that we need to create in every subject, whether it is relevant for us or whether it is not relevant for us. And then mastery is something that is very much relevant for our field. Maybe one or two different area of interest that you need to choose. Like what I did in my life, I did finance and as well as technology. Today, if there is a role in cloud, if you are a cloud architect, the most important thing that you should know that without finance, you won't be a successful solution provider in the technology area, because the just-in-time investment kills your project priorities and stuff like that. Those days we used to invest in such a way that conservatively, for we will predict for next 10 years how much is the size of computation is required, how much is the storage is required, and what are all the licenses are required, what is the size of the hardware that we need. Those things are not actually the problem statement today, because we have moved everything virtual world. So in cloud, you just whenever you need, you add computational capability, more computational capability in the month end, and in the lean period, you can reduce the computational capability. If you have volume of transaction is more, you can increase RAM size. So all these things are like just in time plug and play kind of a matter, where today AI helps a lot to predict the requirement of your investment. And it is most important thing that only one thing that we need to know: how to command artificial intelligence. If you are able to command over AI, UHI is your human intelligence. So we have to build capability of commanding the AI. That is why this example of Sanjaya and Dhritarashtra that I have begin with. I think you might have now some kind of understanding that how it connects basically. Yeah? You have any questions up to this point? I think I'm. Anybody can ask some questions. Okay.
The Karthik Gani has raised a question, but We can just see it in the end towards end, or can I just raise it now, sir?
Yeah, maybe I think, say we close those questions which is related to this particular part, generative AI, how we can, how we can use this in the knowledge management area, because that is the most important thing that the youth of current generation has to understand the potential of your generative AI, where you can place it in your day-to-day routines. If you have any questions, maybe I think you can shoot it out, or I think we can move it to the end of this session.
Yeah, we can move it to the end, sir. Yes, sir.
Yeah. Okay. Now the next most important thing is monetization of the skills. Assume that you have acquired some skill. How we monetize the skill, right? In the knowledge management, I was telling about the four phases. One is awareness and mastery and maestrio and practitioner. So the fourth phase is where you monetize your skill. How you monetize the skill, that is actually something I'm going to demo it to you. Let me give some kind of a example. um, how this generative AI is basically helping people at the learning. The most important thing that how you can produce useful solutions, how you can build some kind of a useful solution, which is basically the first session, the first part of our session is we learned how we learn something that is a kind of a new area of interest. Now we have learned something that we were about to monetize it in such a way that would be helpful for us, building certain solutions. So currently what I am actually showing you, I have a, CV, any CV. Basically you can upload any CV and you give a prompt. There is a prompt that I have, that you give a prompt, and what it will do, it will create an HTML code for that particular prompt. This particular PDF, if you open this PDF, some of the information that is currently available here is as a PDF file, is a that contains some skills and personal projects, and then the organization where he served, and his certificates, language, interest, and work experience. You can see this particular PDF is unstructured data. It's not in a tabular form. You just need to understand this, and it has a certain text. Now what I have done, I am just uploading this particular PDF file to the chat GPT, and I am giving a prompt. And what I am doing, I am collecting a HTML code. It is writing an HTML code. Now I'm going to show that in the browser. How it has transformed the PDF file what we have seen. You can see that it is creating a kind of infographic CV. It's a the original PDF file what you have seen is not this one actually. Now you can see that a kind of a more beautiful infographic CV, which is basically taking the PDF file and it is using the OCR, it is extracting all the text and it is constructing a new format of CV and it is adding certain things. You can see the skills, technology, and you can see there is something called productivity focus, a pie chart. I think now you can go to the code and you can understand that what the prompt it is. Given any resume PDF as input, generate a high resolution 2-columnar infographic resume as a fully standalone HTML file ready for seamless PDF export. Following strict professional design guidelines, how the layout is supposed to be, and design specification, what is the color that we need to use for the box shadows, for the text shadows, and then highlight colors. And also there is one section where we are creating a pie chart. You can see there is a standard chart embedding format. You can see the canvas name and stuff like that. And you can see the data is derived from the PDF file. Only we are providing the color code. You can see there are 5 part of the pie. So the top 5 area of its expertise is picked up and it is coloring into 5 different parts in the pie. And this particular code is being replaced with the original values, and that original values is computed based on the context actually. And it is, it is, if you see the code here, you will understand what and all it does. See here, the data has been arrived in such a way out of the PDF file, the original CV, 30% of the information is related to embedded development. Hardware and testing is 25%. Protocol implementation is 20%. And you can see how this is possible. Learning and certification, project work, because he is a fresher. It is filling learning and certification, and also his project work, what are the projects that he did. So ideally, his profile is captured in such a way, 30% embedded development, hardware testing 25%, and protocol implementation 20%, learning and certification 15%, and project work 10%. This is how he is spending the time. How his productivity of a day is split. And it is adding the color what are the color that we have given, that color has been embedded here. This is a script basically coming from our prompt. So what we need to know here, we need to know how to command the artificial intelligence to achieve whatever that you want. And everything is possible in a blink of eye here, because this code is getting generated, and we are just saving this as a HTML file, and we open the HTML file from a browser. This is what we were doing here. So the potential of generative AI is highly commendable. I think it will this entire idea of trying to understand what actually the generative AI capability. I have shown three things here. One is how you really learn something using the generative AI, and how you use generative AI to develop certain solution, and how this solution is really help you to build some kind of a monetization, right? How you create some kind of a the real productive result out of your generative AI skills. This is actually the main objective of this particular session. Now we move on our core topic, where we will be we are going to discuss about how the quantum computing and AI, generative AI, has been fusioned in our day-to-day, day-to-day routines. I think the most exciting topic that we are going to discuss right now. I just want to collect a certain kind of understanding about music, Indian music, right? Indian music, or I think in India we have Carnatic, Hindustani, and then you have the major is Western. There are three different music that we have. The Hindustani and Carnatic music are very very less people who learn it, and who maybe have the passion of understanding what the music is. How this Carnatic music can be consumed by a layman. I mean, layman means somebody who does not know anything about Carnatic music is going and sitting in a sabha, right? We call it as auditorium. So in the Carnatic music world, they call it a sabha, and they will go and listen to the ragas. How these ragas basically classified, how these kind of how it is possible for me to understand somebody Balamurali Krishna, or some some Hindustani player, he's singing some song. What is the swara it is? What is the raga it is? What is the kirtana it is? What is the difference? All these things. This is the major thing that we used to discuss. I think the music is something we all we all really love it, and we want in such a way to understand something. At least we know what the raga it is. That's what actually my interest in getting this project. We did something called raga classifier. Raga classifier means some audio clip that you record, and you sample it, and you label it, and you figure it out. If there is somebody is recording similar audio, if you're listening through your mobile microphone, some audio, you can understand that what audio it is. I mean, what Carnatic raga it is. That is what actually the idea of this particular project. You see here, we have 72 primary ragas in Carnatic music. We call it as, I think, the gender ragas. How this raga is basically, derived. There are certain swaras. Those swaras are basically the presence of certain octaves. We call it as the arohana and aurohana, right? Sari gama padani sani taba magari. Like that, you have arohana and aurohana. You just have that the forward note and reverse note like that. And these swaras are basically where you have ga, ri, and then you can see there are certain kind of notations here, ni, dha, like that. You have certain kind of combinations. These are all basically completely for me it's a human stuff. I think somebody who is more devotional, somebody who devoted his life from early age, from 3 years old, somebody who is learning the music, he would be able to listen and understand what exactly this raga is, and where the difference is and stuff like that. I think that is where uh, I just placed this solution, how we help the man who does not have any exposure to the music can understand what raga it is, what is the raga the music belongs to it. And we have certain kind of an understanding. These slides are currently of no meaning for anybody. I think I can give these slides and you can go ahead and you can, if you have some kind of a musical understanding, you would be able to decode this. But what you just need to understand for us, how this particular solution took place. Some solution, there are certain steps, there are certain kind of a comprehension, and there are certain kind of an understanding basically. And then we will put across we will convert the natural problem, business problem to or life problem to technical problem, and then we will technically solve it, and then we will render the technical solution to the layman for his consumption. That's what actually the journey of any solutioning. So you just need to understand the steps, what the steps that we have done in this particular journey. Here the swaras have been understood, and we have a problem statement. The melodic framework found in Indian classical music composes of a sequence of swaras depicting the mood and the sentiments. Indian music has 7 basic swaras: sa, re, ga, ma, pa, da, ni, and it is also having reverse of it, aroganam and avroganam like that. And then you have 12 swarasthanas and 16 swara variations. And what happens, this 72 has been further derived to somewhere 2600 subsidiary ragas, we can say secondary ragas, 72 primary and some 2500 secondary ragas. That is very huge list. We are not getting into that, and we don't have any domain knowledge. We will be having certain kind of an understanding, that is basic understanding, that is required for classifying the music, classifying the ragas. We have taken certain experts to classify the ragas and stuff like that. And when the project was started, we did not have any knowledge. The team went through the internet to understand the basics of Carnatic music. We have contacted many domain experts among them, and team has gained knowledge on below topics: swaras, notes, frequencies at which they are generated, structure of raga, maximum length of a raga, how much is the extent that we need to record and see, 10 seconds or 33 seconds or 100 seconds. Based on the number of seconds, the number of tokens also increasing and parameters increasing, and computational space and computational power, everything is increasing, right? So you need to understand it's a very big big problem statement. Theory behind octaves and thalam. Raga is not alone, you have thala also. And difference between Indian classical and Western notes. Western notes are very sharp. Indian notes are different from Western notes. There are two differences. There is something called gamag and something called alabana. Gamag means repeating the same note again and again. Alabana means stretching a note and swiftly moving to one note to another note is called alabana. Like that, you have certain kind of differences between Western and classical music, and they call it as alankaras. Alankaras like gems. The the way that how the ornaments, right? The ornaments that we wear. The music also, classical music also having certain ornaments, that is called alankaras. Yeah, music file is sampled. Now we are getting into technology. A music file is sampled at a defined rate and segmented into frames. There is a package called Librosa in Python that we use. And the length of the music file we sampled for 10 seconds, because the more than that, it will be like cumbersome for us to handle. And total samples, we have done 10 into 22,050. So 2,20,500 samples we took. And hop length 512. And then frame length, sample rate into hop length. This is what the frames that we need to understand. And the number of frames in music file is 430 frames. Spectral centroid. I think, these are all little technology. Spectral means the length of your, the vertical length of your wave, and temporal means the horizontal length of a wave. That is what you need to understand. It is just a layman understanding of any audio waves, right? And MFCC is a key metric that defines, that is very much helpful for understanding the audio frequency. The human perception of audio frequency is derived by male scale, that is called MFCC. You will understand the definition of that in the next slide. There is something called CQT, is similar to our Fourier transformation. That is actually using the you just need to understand multiple voices, multiple instruments and sounds with various different frequencies are combined together in one single frequency. From one single frequency, curve, audio wave, you need to break out all other different frequency waves. That is why we call it as the Fourier transformation here. CQT is similar to that. Spectral metrics. These are the metrics basically that we used. We captured various computations and metrics. Spectral metrics are the metrics as a spatial metrics. Your, the audio frequency positioning, the centroid of mass, and then the position of the mass in the Fourier transformation is related to the spectral metrics. Here we are using spectral centroid, spectral role of flux, bandwidth, contrast, flatness, and then MFCC, male frequency, sepstral coefficients, and then discrete cosine transformation, linear predictive coding, bar scale, ERB, all these metrics that we used. And then there are certain metrics called time, temporal metrics. That is for the stretch of each note. That is zero crossing rate, short time energy, root mean square energy, and then temporal centroid, auto correlation, temporal modulation, contrast, pulse clarity, attack time, decay time, sustain time, release time. And then we have certain surround sound related metrics that is called chroma features. These are all advancements in in the modern Atmos or Dolphy technologies actually, where they have added certain kind of chromogram. That is basically the position of the sound, where the sound has to be generated. That is actually a 3D surround sound that we are achieving using these metrics. This chroma vectors, chroma energy normalized statistics, and chroma variances, deviation, chromogram, chroma based pitch class profile, chroma autocorrelation, and tonal features. This is actually the human voice that has been changing. The tone has been getting changed when the human is singing. Maybe male pitch and female pitch. Instrumentation. Instrument means veena, or maybe violin, saxophone, or trumpet, like that. You have piccolo, like that. We have different kind of instruments. So each instruments you classify with these tonal features basically. And then time domain. These are all the different kind of metrics. Almost somewhere around 350 metrics that we analyze. and we pick up those metrics for for the extraction, and we have the thorough working code for extracting the metrics from the audio file. You just input the audio files to this function called extract features. It will extract everything from the from this audio file. You just need to give the MIDI sequence file, MIDI extension. And the MIDI sequence file you will create using the Libroso package from the Python. That's how you need to understand. Then the next thing is we use classical SVM. Classical SVM is support vector machine to classify your metrics for the given raga. So here these metrics are for every audio file that we generate, and we label it with the defined ragas, and for every new raga that is unseen raga, we train the model and we test it and we validate it, and we use support vector machine for the classification of ragas, because it's a because this particular data set is sparse data set. We are using support vector machine for classifying these. And there are two variants we have done. One is the support vector machine to classify, and as well as quantum based SVM, that is the quantum support vector machine. That is also we have used for the for this particular problem. And the interesting is we have not just limited ourselves in such a way that QSVM. We just even tried with the QNN, the quantum neural network for the classification. And I have the full detail about how we implement and stuff like that in these slides, and you can go through it. Let us understand the implementation. You can see that what we have defined forward self input features. This line defines the forward method, and we have quantum circuit. So in the quantum computers, what we do, all your as per our mathematical understanding, every complex number in a computational plane, we need two angles, right? I think two angles required for representing any complex number in the computational space. Our normal numbers are transformed into angles, and the angles embedding is what we use in this step. Actually, angle embedding is called how we transform this the numerical representation in your normal normal data into angle data, so that you will be superpositioning and charging the particles in the imaginary sphere. How each number is being represented, you just imagine in the quantum machine, imaginary sphere, the north pole and south pole. North pole is basically any particle that is charged near to north pole is basically you say 0, and if it is charged near to south pole, it is 1. And there are certain kind of mechanism, the physics mechanism, like slit test gun, that will change the direction of waves, right? The same way, there are certain mechanism that will change the polarity of this particle. So the 1 becomes 0 or 0 become 1 in the computational sequence by moving the particles from one pole to another pole. That is actually miraculously happening inside the quantum computers, basically. That is how the quantum computers, performing all the computations. You embed the numbers as a charged particles in the imaginary sphere, and based on the location of the particle, it will compute the the values, whether it is 0 or 1, and the entire mathematical computations are happening by moving the polarity, the position of the particles, and we are able to achieve, the entire computation. And the question here is why we need for this problem a quantum computer, or maybe how I could choose this as a quantum problem statement. Why this is a quantum problem? Any such a kind of guess? Anybody from audience? Okay. See, the audio classification, when you are increasing the length of an audio file, the size of the data, I mean the size of the parameter exponentially grows. That is the reason the normal computers struggle to classify any such a kind of an audio problem, because it is horizontally, you are recording. I have just used 10 seconds in this demo, but if you want to improvise the quality of the audio classification, you needed to record more than 30 seconds of a clip. So for more than 30 seconds of the clip, you need to use highly computational machine and highly computational high storage devices. So this particular example is an apt example for the quantum world. And what it does, what we have achieved in the normal our normal PC, our cloud with the GPUs. We achieved a training data set accuracy of 58% and test accuracy is 52%. Whereas the quantum enhancement, it has given 63% of the accuracy with the same data, and we have the test accuracy of 57%. We are able to classify a 10 seconds of clip with a 60% accuracy in our real life, what raga it is. So this is our the first step in our raga classifier, and we are we have certain applications that is available in the Android. I think you can use those applications. You can try it out. It's fun, all real fun. And what is our project finding? Throughout this project, we aimed to explore the potential of quantum computing in enhancing the performance of raga classification. We implemented the quantum support vector machine and compared its accuracy with the classical support vector machine. And our experiments demonstrated that QSVM model achieved superior classification compared to the classical counterpart. So this results suggest that QSVM is exploiting the quantum resources in generative AI. When you are able to create, when you are able to understand the raga, you would be able to create the music. I think how these kind of solutions are becoming the part of part of your life. I will be going to play some kind of some solutions. You just you just need to understand how the music has been transformed, the way that today you just listen to this, maybe you watch this. There is a product right now in market that is called Rolly Airwave. Based on the hand gesture, you can see the music, the camera is watching, and it is actually giving you a kind of an amazing experience in the music. It's not just playing with the keyboard. The hand movement, raising the hand, increasing the pitch, tone, rhythm, and as well as sliding and gliding. You can watch. There are multiple. I think the multiple clips are there on this product. You can take note of the Rolly Airwave, and this product is a European-based product. And you have a keyboard. There are 5 different ways the music is being created in this keyboard, and it is basically creating music in such a way that touching, tapping, lifting your fingers, sliding and gliding are the different way that you raise music. It is an apt companion in classic music. You can achieve alabana and gamag in the keyboard produced by Rolly International. It's a European-based company. I think we have 10 more minutes. I think seven more minutes for for your question session. I think we are reaching the end of our presentation. The next step that what we have in this project is, we want to more experiment on, the audio classifications, and what will happen if you are able to provide such a kind of a robust tool that classify the audio. You just need to understand, it has a huge potential in such a way that you create the music, the human-like music. It's not the machine music basically. So human-like music in the near world. I mean, in the near future. Yeah. Thanks for you guys. For passions and listening. Do you have any questions? You can
Yes,
shoot
sir.
out the questions. Yeah, please.
Thank you for your wonderful session and great demo sort of thing. Thank you, sir. Thank you so much. We have some question in the chat box. I'll first post out that questions.
Right.
First question. Mr. Karthik Dani. He is just. I wanted to ask something like about NQM, National Quantum Mission, started by Government of India to spread awareness among the young minds. So he's just asking that how can he start a quantum computing journey? He just asking how to have that roadmap.
Actually, the pioneer institution today, IIT Delhi, in collaboration with, there are 4 or 5, courses are there in today. There is something called the RR Academy. They are doing the quantum research, and IIT Delhi, in collaboration with the SRM University in Chennai, they have launched an institution called Gigkri. They are dedicated. I think they are the first few quantum pioneers. They have a very wonderful program in quantum computing, where you can master the subject. And even today, everybody is having a kind of a course. In all IIT is having a course. IIT Madras is having a course. IIT Roorkela, IIT Delhi, IIT Kurukshetra. Everybody is having a course on quantum. Today, quantum computing is basically it's a free of cost learning. If somebody knows mathematics to +2 level, let us understand that this is very much important. What quantum computing is: physics plus maths. Physics plus maths. You are doing trigonometry, and then you are doing physics, this Fourier transformation, all those things basically. So these two are mixed together. These two learning, the calculus and calculus, that is something that you might already have studied in +2. Up to power rule you just need to know, and then you just need to know the Fourier transformations and stuff like that. I think the digital signal processing, if you have a subject, I think for you it is just a cakewalk. You can just simply learn this quantum subject basically. Quantum physics, it's not that complex stuff. because I myself is able to crack. I think the people from the computer society is easily to crack it. And then the second most important thing, what you just need to understand, application of this technology in your real world problems. There are today commercial services are available. The Google is coming with Circ, CARQ. Circ is a product in Google Cloud, and Qiskit is IBM product, and you have Amazon Bracket, BRAKET, Bracket, Amazon Bracket is the quantum product. These are all services available already, commercial services available. To play with, to begin with, some sort of learning. Qiskit is completely free. IBM has open sourced it. I think it would be open source means you have certain kind of limitations in running the, it's a learning environment like a Google Colab. IBM Qiskit is the place where you can learn. IBM is having a lot of courses on Coursera, Udemy. I think, you can subscribe for some courses of quantum computing and stuff. Even I think in India, the Swayam.in Government of India initiative is having NTPL course on quantum computing. I think there are a lot of initiatives that are happening. In terms of the NQM, the National Quantum Machines, India in last financial year, Government of India has allotted the budget of 8,500 crore in total. 3,500 plus 5,000. 5,000 for infrastructure, quantum. The first quantum project is Indian Railway. The Tatkal quantum search that we are doing. This elastic search is the first quantum project that is in the run right now. And then you have lot many other private institutions like BITS having BITS is having courses. You have the CMIT is in Bangalore is offering the courses. There are certain private institutions also is providing very good quantum machine learning related courses. The first step is, the baby step for you is understanding the quantum physics. And then there is something called Blocksphere, BLOCSPHERE. Blocksphere is the is the tool that available on the internet that would help you to understand that how this superpositioning and stuff like that, it works like that, and you can play along with that, and you don't need to go and begin something as a paid course. Before you start something, you go to ChatGPT, and after our recursive mastery prompt that I will share to you guys. So you just shoot out and say that quantum computing has your subject. It will take you as a layman step by step of learning what the quantum computing is. And then after some point in time, you can go for paid courses and stuff like that after creating some awareness. Any other question?
So we have two more questions in the chat, sir.
Yeah, okay, go ahead.
What are the barriers in adopting quantum computing in a real world AI applications?
Actually, there are two issues in in commoditizing this technology today. The one is it is more kind of an industry specified settings, like the quantum is fragile in terms of the way that it is storing the information in subatomic level, and you can't carry it as a device in the way that how we carry our laptop. Maybe we expect in future there are some quantum simulators. Basically, it's not real quantum machines. It is like a quantum simulators that you will be able to get it as an add-on, like a GPU box, some some quantum machine that you will get. Google is in research right now. How we can commodize this technology, but it will take some time for us to reach that particular expectation, because it has an industrial setting. The highly fragile EMF and stuff like that. It is simply in room temperature it will collapse the quantum status and stuff like that, and it would also create errors in reading. So there are certain technological glitch right now in providing this technology as a end user computation solution, like a laptop or maybe a palm top or something like that, what we are expecting. But it will take some time for us to reach that. Yeah, maybe in another 2-3 years, we will get this resolved.
Thank you, sir.
Yeah.
Next question from the time of registration. How in India ready? How is India ready for the quantum evolution? How can a student from Tier 3 college can study or excel in the field of quantum computing? I think you have answered through the
Yeah, this
last
I
question,
have
but can
already
you just
covered. Yeah.
elaborate?
There are
Yeah,
three
yeah.
things. There are three things that we need to understand here. One is India ready for quantum technology? Yes. Andhra government is setting up a quantum village. Just imagine, the inspiration of the Chandrababu Naidu. I think it will take some time for us, to get a kind of our own quantum platform. But today we have a platform that is very much technologically equip us in such a way to learn and understand what is all about quantum computing and stuff like that. As I said, IBM Qiskit, QISKIT. Qiskit is a package that is in Python you have a client, and in Java you have a client. You can use Python to connect to the Qiskit server. You have a lot of materials on IBM Qiskit site. You can go ahead and you can start learning that. And then you have a lot of courses, as I said, available. The commercial courses are being launched. Gigkri is an institution I recommend for learning, because they are very much pioneer. They are already 3 years old in this technology in India. I think they have matured engineers and trainers, so that I think I could recommend. Apart from that, you have the NTPL courses. As I said, the beginners, you can learn the quantum physics and quantum computing, and then quantum machine learning. Like that, you have steps. That's how you need to progress.
Thank you, sir.
Yeah.
Can this approach be extended to other creative domains like visual art or storytelling?
Yes, I think the sky is the limit. As I said, what the experts today. It has already. I think there are certain hackers are being using these. The quantum signatures are not understood by any antivirus applications available in the market today. The reason is, the antivirus applications are only having the signatures for the normal computing space, not in the quantum space. So quantum computers has given a major challenge is cryptography, breaking the blockchain cryptographical code. Quantum has already broken the code. So they have pulled the quantum servers, the quantum chips, basically. The recent Willows. There is a chip called Willow has been introduced. It was up and running in the quantum world, and then the Google has pulled down because it has breached the normal expectation. it is far beyond the imagination. So you can simulate the entire cosmic systems, with the help of quantum. Just imagine the way that how the capability of this technology. Every atom in the quantum, every atom in the cosmic cosmology can be simulated with the help of quantum computers. Currently, we have 128-bit. I think 32 qubit quantum computer that we have is the maximum. Google is trying to get 128 qubit. 128 qubit will perform a computation in a blink of eye. That is comparing to the computation of 44 years of supercomputers. Whatever the computation it will do, the quantum computer will do.
Thank you, sir. Thank you so much.
Yeah.
Any other questions from the participants? You can just unmute yourself and you can ask, please. Yes, Shamim, you can just ask.
Good evening, sir.
Yeah, good evening.
I want to ask you that can quantum advantage be demonstrated for practical and real world problems?
Yeah, I think what you have, what the demo that we have shown is, is a kind of a real world problem where the music classification, right? The layman needs some kind of a solution. I will go and sit in classical music concert. I will just shake my head. I don't know what the music it is, what the raga it is. So it would help that to me understanding what the raga, underlying raga it is. It is just if this evolves, what will happen that you would be able to understand the sentiments of the people, the emotions. It will interpret the emotions, and it will precisely deliver the content, human-like content, to the world, right?
Thank you, sir. And I have one another question, sir. Shall I
Okay.
ask?
Yeah, go ahead.
Yeah, the thing is, can we simulate quantum complex quantum systems like high temperature superconductors
Okay.
accurately with quantum computers?
Exactly. See, the idea, what you just need to understand here is the idea of quantum computers. You just need to know that, I think, the Moore law, right? The Moore law is saying that exponentially we are increasing the computation capability in the normal silicon chip, right? And Intel CEO, ex-Intel CEO has told that we have reached the the mini school. We can't further reduce our reduce the size of the chip. Already 54 million transistors per nano square meter that we have reached, and further we can't reduce the size of your silicon chip, right? Our processors. So the quantum computer is the next technology where the Moore law we are going to apply here. So here there is no kind of a glitch. The sky is the limit. You can store the invisible atoms, right? The subatomic level in photon. We are charging the photon in subatomic level, and based on the charged photon we are computing. That is how that it is working. This is one technology. Another one technology is also the phonons. Instead of photons, phonons also the another variants that they are expecting. The constant sound, that is actually the source of constant sound is required for that. Maybe they use mushrooms that is generating low decibel constant sound from it, and low cost computational machines, quantum machines will come using phonons in future. We mushrooms will be the costlier costlier product maybe. I think you just need to understand that the phonons also and another source of computation. The phononic waves can be used for creating quantum computers.
Thank you, sir. Then I have one more last question, sir. Can I ask?
Yeah, go ahead.
Yeah, we have achieved quantum supremacy in controlled experiments, such as Google's
Correct.
Sycamore. But can we find can we find real world problems where quantum computers outperform the classical ones in useful way?
Yeah, I will give you some. I think I'm just trying to figure it out for you to help you to understand. In normal quantum computer, normally in our machine learning, we do logistic regression, right?
Yeah, sir.
You know what is logistic regression, right? It's a
Yeah, yeah,
binary
sir.
classification, right?
Yeah, sir. Yeah.
uh, 0 or 1, that's what the binary classification that we do with the logistic regression. So just imagine in the process where you have a sparse data, where more than let's say 15,000 variables. What do? You use some kind of a supercomputers to do this, and you do PCA, the primary component decomposition that you do for reducing the number of variables, right? You don't need to do all these circus. You just load the data as is into the quantum space, and you use quantum logistic regression. That means there is no such a kind of sparse data issue, or maybe there is no such a kind of a, the computational question, right? Reducing the variables and stuff like that. And the future engineering is not a topic in quantum computing. You don't need to do future engineering, future selection or future engineering in the quantum world.
Thank you so much for your detailed explanation, sir.
Thank you. Any other questions, ma'am?
Any other questions? Okay. So there are no further more questions.
Yeah.
So I would like to propose the formal vote of thanks. Thank you, sir. Thank you for your detailed session on quantum plus AI fusion. So you started with the telling that it is the quantum era, and you just briefed with the two demos. So one was on that recursive master, and you are how to plan for a particular module, how to get that, and the second was on fine tuning about a CV. So you just started with chat gpt, how you just mentioned that how the unanswered questions can be resolved. So you started with that, and then you spoke about awareness, mastering, mastro, and practice. So, and you stated one thing like commanding AI will lead to human intelligence. And also, you just spoke about the generative AI and introduction to Indian music. So, you just talked about the ragas and the secondary raga, and how classification is required, and how classification of ragas, how it can be done. And the speaker also mentioned about the metrics like audio metrics, and then the spectral metrics, the temporal metrics, then the chroma features, there is a surrounding sound features. And also he mentioned about the time domain features. So the project that they have carried out has taken around 350 metrics. He mentioned that, and they first initially did the classification with the classical SVM, and he also mentioned about what is quantum SVM and what is it thing, and he also just touched about quantum neural networks (QNN). So he just briefed, and also he just gave the demo also with some live things. Thank you, sir. And with the in the question answer session, he just mentioned about how to start up with like and what is quantum physics, and then what is block sphere, and how we can enhance through the different tools and through the different courses like with through NPTEL, all those things. Thank you for the wonderful session and wonderful Q&A session also, sir. And before ending up this day, I just want to mention that we are having one more session on 28th of May between 6:30 to 7:45. The speaker is Mr. Venkat Krishnan, consultant investor, ex-director Infleon, Symphosis, USA. The topic is on trends in semiconductor industry. I request all the participants to join, register, and you can just find in our website. And also, when you just receive this particular registration mail, you must have got that link for the registration, credential detail of this particular session. You must have received the registration details of that particular session also. Kindly register and enhance your knowledge. Thank you very much. Thank you once again, sir, for your wonderful session. Thank you, all the participants.
Thank you all.
Thank you, Lakshman.
Yeah.
Ma Divya, have you stopped streaming, ma?
Yes, ma'am. Actually, recording is stopped, ma'am.
Recording, recording I stopped, but I'm asking about the streaming. Okay, okay. Thank you, ma.
Thank you, ma'am.
Thank you, Vishwa.